Okay. Good afternoon, students. Today we see next numerical on bisection method. So, in previous lecture we have covered numerical on bisection method based on iteration criteria. So next we'll see today next numerical, that is again based on bisection method based on iteration criteria. So the question of the method is bisection method. Bisection method. So the question is determine using bisection method a root of equation x log x minus 1.2 equal to 0 up to 4 iteration. So the question means the function equation f of x. F of x is given as x log x minus 1.2 is equal to 0. Function equation is given and it is asked that perform 4 iteration. Up to 4 iteration means here we have to find the root of equation up to 4 iteration. So the solution. What is the solution? First step. First step is what? Here the initial guesses x1 and x2 are given. x1 as 2.5 and x2 as 3. Initial guesses are given. Here, for this initial guesses 2.5 and 3, the condition of convergence is f of x1 into f of x2 is less than 0 is the condition of convergence. Means here our next task is to find f of x1, f of x2 and check either our initial guess 2.5 and 3 is correct or not. Okay. So here find first f of x1. Here we consider x1 initial guess as 2.5 and x2 as 3. So next step, find f of x1. Find f of x1 means f of x1 means we have to put x1 is equal to 2.5 into function equation. Means here x1 is 2.5. Just put x1 is equal to 2.5 into function equation. So f of x1 is equal to 2.5, that is x, into log of 2.5 minus 1.2 by calculation. This f of x1 is equal to minus f of x1 minus 0.2051, that is negative. F of x1 is negative. Similarly, find f of x2. How to find f of x2? How to find? Here x2 is 3. You have to just put x is equal to 3 into function equation. This function equation you have to put x. X is equal to 3. That is x2. Our x2. F of x2. This x2 here it is 3. So f of x2 is equal to 3 into log of 3 minus 1.2. By calculation, this f of x2 is positive. F of x2 0.2313. 0.2313. F of x2 is positive here. This positive. Here we have calculated the term f of x1 and f of x2. So students, what is next step? Next step is we have to check whether our assumed initial guesses x1 and x2 are either correct or not by what? By using condition of convergence. Condition of convergence is f of x1 into f of x2 less than 0. Here we have to put f of x1, means we have to multiply here, multiply f of x1 and f of x2 and check whether it is less than or greater than 0. If it is less than 0, then our initial guesses are correct. If it is greater than 0, then our initial guesses are wrong. Then in that case, we have to consider next initial guesses. So next step is we have to check f of x1 into f of x2. So f of x1, f of x1 is minus 0.2051 minus into f of x2 0.2313, that is equal to comes minus 0.0474. So this term minus 0.0474 is what? Less than or greater than? It is less than 0. Minus 0.0474. This term is less than 0. Means what is the meaning of this? The meaning of this is nothing but our initial guesses is assumed initial guesses are correct. Assumed initial guess are correct. Assumed initial guesses are correct. Here, which initial guesses? Here we assume x1 for this function or for this equation. We assume x1 is equal to 2.5 and x2 is equal to 3. These initial guesses are correct for this function equation. Here we check whether initial guesses are correct or not by using condition of convergence. The next step we have to perform for iteration number 1. So for iteration number 1, what is the procedure for first iteration? So iteration first. Iteration first. Again, for iteration 1, okay, we have x1 that is equal to 2.5 and x2 that we have used x2 is equal to 3. But what is bisection formula? Bisection formula is What is bisection formula? x3 is equal to x1 plus x2 upon 2. Bisection formula is x3. x3 is nothing but root of equation. Is x3 is equal to x1 plus x2 upon 2. Here this x3, x1 known 2.5, x2 also known 3. So 2.5 plus 3 divided by 2. So by calculation, x3 equal to 2.75. x3 is new. x3 is equal to 2.75. So So students, up till now iteration 1 completed. Iteration 1 completed. But the question is, when we start for iteration 2, the question is, when we start for iteration 2, what are the values of x1 and x2? These values are changed. Either x1 change or x2 change. These initial guesses to find further new root of equation. Okay. And how to find new values of either x1 or x2? Let us see here, student. We have x1, f of x1. Sign of f of x1 is negative. This one is negative. F of x2, sign of f of x2 is positive. Similarly, find signs of f of x3. Means here we have to find f of x3. Means we have to put x3 equal to 2.75 into function equation. That is f of x3 equal to 2.75 into log of 2.75 minus 1.2 x3. 2.75 minus 1.2 by calculation. F of x3, the value of f of x3, our answer for f of x3 is equal to positive 0.0081, which is positive. So here we have f of x1. We have f of x1 negative, f of x2 positive, f of x3 again positive. So what is the meaning of this positive and negative? Means here by sign convention, we have to use x1, x2, that is for iteration 2. For iteration 2, x1, take x1 as it is. That is, for previous iteration, what is the value of x1? x1 is 2.5. But because f of x1 function equation sign, only f of x1 is negative and f of x2 and f of x3 are positive. Here, when one function or out of 3, if one function is having same sign, the opposite sign of other two, we have to take that f of x1 is nothing but at either x1 or x2, same as it is for next iteration. Here f of x1 is negative sign. Out of 3, one function is having negative sign. That's why here take x1 directly as 2.5. x1 is equal to 2.5 is 2.5. x1 is 2.5 is for previous iteration we use x1 is equal to 2.5. That we have to continue for iteration number 2. But what about x2? Here the function sign f of x2 is positive, f of x3 is positive. So for x2, replace x2 by x3. Means take x2 as x3. That is equal to x3, that new root of equation that we have already found out, x3 equal to 2.75. Means, what is the meaning of this? For iteration 2, we have to use x1 is equal to 2.5 and x2 equal to 2.75. For iteration number 2, use x1 as 2.5 and x2 as 2.75. We have to take x1 and x2. Next step. Again, we have to repeat what x3. x3 equal to x1 plus x2 by 2 means we have to find the new root of equation. That is, what is bisection formula? Bisection formula is x3 equal to x1 plus x2 by 2. Again, find x3. x3 equal to x1 plus x2 by 2. x1 is 2.5 plus 2.75 divided by 2 means x3 is equal to 2.5 plus 2.75 upon 2, that is 2.65. 2.625. That is, again, new root of equation x3 equal to 2.625. Again, find f of x3. Again, check signs of f of x1, f of x2, f of x3. And if out of 3, one function is having same sign, opposite sign of other two, then you have to take directly either x1 for previous. If you use for previous iteration x1 as 2, you have to repeat, or take for next iteration x1 is equal to 2 as it is. But what about x2? We have to replace x2 by x3. Either we have to replace x1 by x3 or x2 by x3. Means x1, in some case x1 is constant, in some case x2 is constant. So in this way, we have to find what number of iteration n is equal to 4. We have to repeat this procedure for 4 times, and at the end of fourth iteration, the value comes x3 as 2.7187, means the root of equation 2.7, the root of equation is 2.7187. At the end of fourth iteration, we get answer for x3 is equal to 2.7187. So 2.7187 is the root of this equation. Which equation? The equation is f of x is equal to x log x minus 1.2. For this equation, by using bisection formula, we find the root of equation as 2.7187. So this is nothing but a numerical based on iteration criteria, that is bisection method. So today we will stop here. Next lecture, take next numerical, that is based on accuracy criteria for bisection method. So today we will stop here. Thank you.